Welcome to Adventures with a Very Small Lathe. In my most recent Watchmaker's faceplate video I used my shop-built tap follower to tap some M3 holes. Because the square end of the tap is significantly smaller diameter than the 5mm shaft of the tap follower and is not long enough to protrude through the tap wrench jaws, I had to grasp the tap in the tap wrench lower down on the cylindrical shaft. This meant I had a weaker grip and had to use less torque to avoid slipping. To solve this problem, I decided to make a dedicated reversible tooltip for smaller taps. The basic shaft turning is the same as for the previous part, so I'll speed that up a bit. The shaft end needed to be turned down to a diameter smaller than the square part of the tap, and for the first end I aimed for 3mm to use with M4 taps. The reduced diameter section only needs to be long enough to protrude between the jaws far enough to meet the end of the tap. The rest needs to be full diameter to fit correctly in the bore of the tap follower. After turning with a large radius insert, I switched to a smaller radius to clean up the shoulder. With an M4 tap in the wrench, the follower fits cleanly between the jaws. The other end is for M3 taps, as this is the size I need soonest for a project. It's a fairly simple part to make, so I can make another if I need to for smaller sizes. The target diameter is 2.3mm. A quick check of the fit before I try centre drilling, as after drilling the walls will be thin and further turning may be difficult. I decided on a 1mm centre drill to ensure the walls were strong enough to stay rigid. As this is very small, risk of breaking the drill is high. I spotted the centre first with a larger centre drill to reduce the strain on the smaller drill. I then switched to a 1mm solid carbide drill after checking the tailstock alignment. I turned the lathe speed down to reduce vibration. The speed was too slow and the pressure too high. The Proxim stock tailstock isn't rigid enough and the force caused the chuck to lift, putting side pressure on the drill, snapping it. The broken carbide drill is now embedded in the part, and despite lots of incredibly inventive suggestions from the YouTube Machinist Facebook group, it didn't seem worth removing it. I had enough spare length to abandon a couple of millimeters and turn them away to start again. My second attempt was with a cheap high-speed steel centre drill so bad that it snapped immediately and I threw it away. The third attempt actually worked. The centre drill is high-speed steel, the lathe is running at a moderate speed without too much vibration, but fast enough for a small drill to cut well. I kept contact very brief at first, adding more cutting oil frequently. As I got a feel for how the drill cut, I increased the duration of each peck, keeping light, consistent pressure on the tailstock feed. The final check of the fit and everything looks good. This has been a really interesting project. It's the first I've tried when some of the features are smaller than I can see clearly with the naked eye, which is good practice for when I finally try out the watchmaker's faceplate. Thanks again to Phil and Pierre for the design inspiration.